Good morning, ladies and gentlemen, boys and girls, friends and neighbors. Today, we're going to talk about Unit 9, Lesson 2 in our textbook. This is called Activity. And we want you to fill out this activity in your interactive activity notebook. Okay. This is going to be a fairly short video. These problems are pretty straightforward. Just want to let you know who's bringing this video to you today. This video is brought to you by, you betcha, Tigger. So Tigger is going to help you do this trigonometry today, and he may or may not show up tomorrow. All right. So you will have a Google assignment, where you're going to take a picture and a Google form. So what we're going to do, again, we're going to use the geometric definition of the trigonometric ratios to figure out what this is. The first thing I need to realize is this thing right here. This is going to be very important. That is an angle. Actually, it's an angle less than 90 degrees. So I'm going to sketch. It's going to be imperative that I can sketch a triangle such that this happens for. I'm going to sketch a right triangle here. And this is going to be a right triangle. And I'm going to let this angle right here be A. This is angle A. And what do I know? Well, I'm going to take this statement right here and I'm going to cosine both sides of this. And that's going to tell me that the cosine of A is equal to 3/5. This actually is a pretty straightforward problem right here. I'm actually going to put this up here because it's going to get in my way there. Is equal to the cosine of A. The inverse cosine of 3/5 equal to A implies that 3/5 is equal to the cosine of A. And this is the statement here that I'm going to use in my triangles. I'm going to get this thing out of here because it's in my way. Okay. So I'm going to use this statement right here and fill in the missing pieces of my right triangle. This should be a little bit easier than what we have been doing. So we know from the geometric definitions of the trigonometric ratios that the cosine of an angle is the adjacent side. Let me plug in my rascal in here. Is the adjacent side divided by the hypotenuse. So that says this side is going to be 3. The hypotenuse is going to be 5. And I can right off the get-go know that 3, 4, 5 is a Pythagorean triple. I can use the Pythagorean theorem to find this missing side, but by this point in your education, you should know that 3, 4, 5. You should automatically know that 3 squared plus 4 squared is equal to 5 squared, i.e. 3, 4, 5 is a Pythagorean triple. So that's pretty easy. So now all I really want then, if I'm back here to my problem, I want the sine of A. Because I let A equal inverse cosine of 3/5. Well, what's the sine of A? Easy peasy, 4/5. Now, many of you will be able to look at this and just say, oh, 4/5, which I hope you can. Eventually, I hope you can. A lot of you at this point can. I can't tell you with respect to next year how important it is for this graphical representation. And we had some more difficult problems on the previous video. In like manner, we need to realize in like manner, pardon me, Tigger, we're going to need to be able to figure out what this is. It's very, very important that I know this, that this guy, that what's inside of there, that's an angle. And whenever I inverse any trigonometric function, the output is going to be an angle. So really what I want here again is the sine of A, because A is this angle right here. Okay, and I'm going to again use a triangle to figure out what the sine of A is. And it's going to be imperative that we can sketch these triangles. Let me get rid of this so I don't. And I'm going to sketch a triangle here best I can. Okay, and it's going to have to be a right triangle. And this guy here is going to be A. Well, what do I need to know? Oh, what does this imply? That implies that the tangent of A is equal to 12/5. And the tangent, if we remember the geometric definitions of the trigonometric ratio, the tangent of an angle is the opposite leg over the adjacent leg. Again, I can use the Pythagorean theorem to find this missing side here. I'm going to call it little c, but many of us should know by this point that 5, 12, 13 is a Pythagorean triple. That 5 squared plus 12 squared is equal to 13 squared. And if you do the math and check that out, you will see that that is true. And so therefore this value here, this c, is equal to 13. We have 25 plus 144 is indeed 169. So 25 plus 144 is indeed 169, which is 13 squared. Okay. Oh, so what do I want? I want the sine of A. What is the sine of A? The sine is the opposite over the hypotenuse. So this is going to be 12/13. Easy peasy. Pretty straightforward. This, like I said, this is going to be a pretty easy lesson. We're going to go to this next, and what we really want you to do is fill out these activities. Eventually, we will be asking to look at these activities. Okay, so here we go. Same thing. This I need to realize. Let me do a divider here. Here I need to realize that my angle this time is equal to the inverse sine of 12/13. And what I don't want the cosine of inverse sine, I want the cosine of this angle A. Angles are the output of inverse trig functions. And you cosine angles, you sine angles. So A is an angle. Oh, and if I look up here, the sine, what does this say? This implies, like this in red, doesn't this imply that the sine of A is equal to 12/13? And look, I can use the same triangle up here. You're darn tootin'. I already have this triangle up here, so I can use this triangle because that's exactly what I have. I have the opposite, 12. I have the hypotenuse of 13. And I know this guy is 5, so I can use this same triangle to evaluate this particular expression, and this expression, cosine, then is equal to the adjacent over the hypotenuse. This is pretty easy. I can't tell you how important it is that you have the graphical representations. They are a must. We're going to go one more example. This is going to be a short video today. And one more example here. Okay, so this is similar to the previous video. Some people were asked for another example of this. What I want is this expression here algebraically in terms of u. I want to put this whole expression in terms of this u thing. And what do I know? What I'm going to start off with is the fact that the inverse cosine of u is equal to a. What I'm going to do is the same thing that I did on the previous examples. I'm going to, let's rewrite this rascal here. What this implies, almost looks like a smiley face, that u is equal to the cosine of a. And now I'm going to take this and create a triangle using the geometric definitions of the trigonometric ratios. Make sure that I know that this is a right triangle. And this, again, I'm going to use this as my angle right here. And the cosine of a, which is u, the cosine is always the adjacent side over the hypotenuse. And all I need to do is I just need to write this as a fraction, because u is the same as u over 1. This is the same as u, and I have the cosine of a is equal to u, just u over 1. So now I'm going to label my triangle. U is going to be the adjacent side. The hypotenuse is going to be 1. And now I need to figure out what this missing side length here is, because why? Because I want this guy right here. I want the sine of a, because I let a be the inverse cosine of u. So I want the sine of a. So I need to figure out k in terms of u, because right now, if I look at this, the sine, very simply, is equal to k over 1, which is just k. So all I really need to do is use some Pythagorean theorem stuff here and figure out what k is. So what do I know? I know that u squared plus k squared is equal to 1 squared. That tells me k squared is equal to 1 squared is 1 minus u squared. Take the square root, 1 minus u squared. And we're going to use this as was stated in another video. This is going to be important for next year for anyone studying calculus. And this is the positive. The reason why it's positive is because we're talking about lengths of sides of a triangle. So k is 1 minus square root of u. So I'm going to go back up here. So therefore the sine of a is equal to the square root of 1 minus u squared. And now I have a in terms of u, algebraically in terms of u. This is my final answer if I have this. So this particular problem is just a repeat. A very short video today, but a very important video. So we ask you, Mr. O'Brien and I ask you that you fill in this activity, and we're going to do the second part of this activity right here, which is a little bit tough. These are some tough problems here. We're going to do this in another video. So I'm going to bid you farewell, and Tigger bids you farewell.